All right, so radicals continue even more. So radicals continued again, second, third time. All right, so one more thing you should know before we continue number 24, that if I have, listen carefully, if I have the nth root of some, the nth root of some value, let me put it in parentheses, a to the n. Nth root of some value a to the n. Right, now let's be careful on this. The nth root of some value a to the n is equal to absolute value of a if n is even. So note that. All right, so here's an example. The square root of negative 3 in parentheses squared. I'll put a little 2 here for you to let you know that's square root. So the square root of negative 3 squared is going to be the absolute value of negative 3, which is going to be equal to 3. And that makes sense, right? Because what is the square root of negative 3 squared? Well, that's just the square root of 9, which we expect to be equal to 3. All right? Cool? But note that if I have the nth root of negative, right? So if I have the nth root of negative, how can I best put this? All right, let's suppose I have negative a to the n, right? Where n is where n is even and a is greater than 0. In other words, just take some number a, and then take the opposite of it and try to take the nth root of a to the negative a to the n. If that's the case, right? So this situation here, this thing here, in this case, is not a real number. So even roots, even exponent is a little bit different. All right. So we're going back to exponent, we're going back to root, and just want to say a few things, and that's what I'm trying to say here before we continue with the lesson. All right. So a good example for that would be if I take the square root. If I take the square root, right, and again there's an invisible 2 there. If I take the square root of negative 3 squared, that's not a real number because that's basically equal to the square root of negative 9, which is not real. This is not a real number. All right, that's not a real number. Okay, so make a note of that, all right? Make a note of that. Okay, I want to say a few more things before we go, right? Just to make a little bit more sense of this. All right, so by definition, note, still talking about radicals, note by definition that the radical, the nth root of, say, a, I'm changing, I'm not using big N anymore because I don't want to confuse it with this little n, is just going to be a to the 1 over n by definition. All right. So example is 9, the square root of 9. You can confirm this in your calculator. The square root of 9 is going to be 9 to the 1/2. So this is a little invisible 2 there, right? The cube root of 27 is going to be 27 to the 1/3. All right, so just make a note of that. And so while you're doing that, another rule to note is that this, if I had n here for a, and let me put a different exponent here. Let me make this a p. All right. In that case, where it's defined, of course, n, the nth root of a to the p is just going to be a to the p over n. All right. So that's going to be a to the p over n. I know it's a lot of rules to think about, right? Another rule that you have to know also is you could look at the nth root of a to the p as the nth root of a raised to the p power. Or you can also look at that as the a to the p done first and then taking the nth root, right? Okay, so all these are the same. Whichever way you want to go, in that direction or this direction, it's the same thing. All right, that's the same thing. Okay.